Well, I'm Ray Trappel. I'm an architect builder, a local architect builder. I specialise in earth building construction. Today we're going to be looking at a tiny house built mainly with a lot of earth materials, and we were quite keen to see how we could explore that. So an affordable house, one that could be fire resistant, one that can moderate external temperatures, winter and summer. And we thought that would be a nice thing to explore. And so with a few other volunteers and other interested people, we've been able to put together this house to this stage. We're still constructing the house. It's built on the Northwest Disabilities Secret Garden site on the Western Sydney University campus. So it's a great education sort of space connected to an education facility. We thought it'd be a good, more public space to have a building of this type that can demonstrate how we can improve our building stock in Sydney so it's able to be available to a lot more of the community, young people who can't afford houses, and particularly homeless people who have access to different, not dole payments, but different payments. Within that budget, they can afford the rental for a house this size. So we thought that would be important to be able to put say a 30 square metre house together that could be rented for $150 a week, and that payment would be easily able to be managed by someone with those payments. And also that house could be paid for either by community a service provider for housing, or it could be provided through people's superannuation, where they could say build a house like this, say $50,000 with $150 a week income, which would be managed by community housing group. They could be looking at a 15% return on their investment. So all that seems to stack up. And also with state compliant development, we're able to do a house like this on a block size right down as small as 450 square metres. So a lot of blocks in Sydney would have land available like this to build a little house on, which would be an affordable house for someone without a house, and they could all relation, or even indeed some people are finding they don't need a large house. They can move into a small garden house, which is what we're calling it, which would have your food production around it. In this side here, we're trying to just demonstrate permaculture gardens and how you can have your food growing, fruit, veggies and whatever, done sustainably. And so we're demonstrating that that's all possible on a very low budget. So these houses can allow people to, because they're simpler to build, they're cheaper to build, and there's a lot of different things we've put in place to allow recycling of materials, to allow the use of on-site materials, as well as having a building that's quite environmentally friendly. So that's our house behind. I'll probably be blocking the view of it, but that's the one we're looking at the moment. We're going to walk through that in a while, and we want to talk in detail about some of the materials that have been used in that construction. And at this stage, it's probably a good point to say we've had a lot of people involved in contributing time and materials. Some people are quite good presenters in their own right, and we'll talk about that as we go through the detail of the building. But there are a lot of people that probably it's a bit hard to acknowledge all those people at this stage, which just wasn't my efforts. I put a bit of design in, and we've initiated a lot of the building, but there've been a lot of people involved in the whole process. So I think it might be time to sort of walk through. And what we're going to do is look at some of the materials. As we first see the rammed earth, they're fairly, again, it's a research thing where we're actually exploring a lot of options for building materials that really haven't been explored for many years in this country. So a few of these things, but we'll talk about it. Let's go in and we'll have a look in detail. Yep. Okay, this is a great place to start. I just want to particularly point out this building material here that we're playing with. Andrew might be able to zoom in on that, Chris. This is a rammed earth wall, but it's done without cement, and it hasn't been done in this country really for probably 40, 50 years. Early 70s, the last time Rick LaPlastrier did a couple of lovely rammed earth buildings in Sydney, which didn't have cement, but after that we started using cement, and we're up to about 10% cement in the typical rammed earth. But there's people in Austria now doing this work without cement. Martin Rauch is his name, and he's been pioneering that sort of work. And so we're basing this off his detailing. You'll notice these little white layers in the wall here. They're a layer that's done with a little bit of lime, and the lime has a bit of clay in it. They call it trass lime. It's a pozzolan lime, and that gives a hard layer. It's a weatherproofing layer. So if you get any erosion over your wall, you can see a little bit of pitting there, but this would erode, but that doesn't. So you get a shedding layer for water. And he's got walls 10 meters tall without much eave at all, and that's able to shed water. So it's a way of detailing earth in a wall without using cement. On the corners, if you maybe zoom on that, he has them a little bit closer, so you get more erosion control there. And we also have another layer as a skirt layer, so any splashing, whatever, and inside the building, you've got that harder layer. So this is cement-free rammed earth. This material that we used for this was a sort of a waste product in a sense, but it's used for road base. It's a crushed sandstone material. We were getting it delivered to the site here for $10 a tonne, which is really delivery costs. So it's almost a free material that had to recycle. We're adding a little bit of clay to that, probably about, it ends up about 20% clay we were working with on this. And we mixed that, we had to activate that clay in the mixer, and then we pushed that clay through the mix with a articulated loader or a skid steer loader. And then we're able to have our formwork, quite strong formwork, and then ram that in. Now this front wall of this little tiny house is 300 mil thick. And we thought it was important to have something solid in a tiny house. It wasn't just done with lightweight paneling, it was done with something quite solid, which helps moderate day-night temperatures, winter and summer. So summer particularly, with some of these earthy houses, we can get 10 to 20 degrees difference between outside temperature inside because you're able to store that night temperature. In winter time, we get the sun in through the windows because it's smaller space, you can warm that up, and we have an internal mass wall too, which is able to moderate temperatures. Later, Doug might be able to put up the plan of this building so we can show the actual plan. But let's go inside, have a look at a few more other walls. What's that? Oh, plans on screen. Oh, good. Oh, great. Oh, thanks for that. You can see with the planning, there's as you go in, there's a living space with a kitchen to the right, and we do have a separate bedroom space. And then we have a small ensuite, and above the ensuite and part of the bedroom, we have a little loft area, which could be used for sleeping or storage or whatever. So it gives that, because it's a high roof, we've got a little bit of room for storage. And because it is a high roof, it makes the smaller, gives a bit more space to the whole room. As we go in, we'll see that. We've used a lot of recycled materials. You see, actually, just with this entryway, we use a standard form. We have this 1.5 wide, so it gives this lovely solid arch shape to the building. That's a standard form that could be used on many buildings. So it's not something you have to make up every time. So there's an economy in that. There's timbers have been let into the side, so we can fix our jams to that. Eventually, we'll be able to fit that out. Yeah, Andrew's got a great shot at the front there. The detailing at the front, we've used fire-resistant timbers, the BAL 29 timbers at the front. They're done in ironbark, and this feathered edge detail is something we use on a lot of our buildings. But it means you don't have to put the barge in. You don't need to put insulation and eave lining. So it cuts the cost a lot, and we call that the feathered edge to the building. And because the iron comes down at the end, it protects the end of the timber, and so we're able to have that lasting a lot better. The rest of the timber isn't BAL 29 timber, it's recycled timber we've found here. And there's a beauty in recycled timber too, once you start cleaning it back, get the splinters off, and yeah, it's a sort of rustic feel. I mean, it's not the only way to do it, but it was a way we were able to do it here because you had access to that material. Again, it does cut the cost of the materials significantly, even though the labour content might be a little bit higher. I think it might be time to head in. We'll have a bit of a look at our space. Again, it's a building under construction. that a lot of it is actually completed. The ceiling was done with recycled office panels, and we did buy some of the bottom timber lining boards, and it's got full insulation to the basics requirements. So that's very important to insulate your ceiling well, and it's got sarking and whatever in that. And you can see the recycled timbers in the ceiling. Yeah, I think so. So inside, we've used a combination of earth building techniques. Probably the first one to look at would be this internal wall and the northern wall. We've done that in mud bricks or earth bricks. We made them here locally. With this earth brick, we've been experimenting with a way of making a much thinner brick, which can be dried most of the year in about 4 days. But this time of the year, you might extend that to a week or so. And a thick mortar bed. So it's more like a cob wall because of the thick mortar bed, and the brick then can be used as forming. Those bricks could actually be made on the floor of the building itself. So it would mean owner builders could be involved in that process if they wish to be. So the actual timeline would be the plinth beam we'd put in first, this beam here. We bring it out a little bit so you've got termite control. That's just put on crushed sandstone road base. And then we can build the rammed earth walls next, which would be the front wall plus the 2 side walls, or the whole side walls. The roof would go up there next, and then owners could come in, make their mud bricks and lay them, or mud bricks could be supplied for the house. You can see in here the actual northern window and how it's shining on that internal wall. That's an important way we moderate winter warmth. We get those internal walls warm, and they radiate heat at night, and they're not losing heat at night because of an internal wall. And on this, we're planning to do what's called a trom wall on the outside, which is a glass wall inside that mud brick, 200 thick mud brick wall, which can, with glass house effect, build up the heat on that wall. So at night, you can get that northern wall under the window radiating heat, and we can still look out there and get the heat going from that northern wall. So that's an important part of this living space, is have those northern windows. At the back here, we've got a small area for a bedroom. We can put a queen size bed in there. We've got a couple of windows in there, so you get extra light. And of course, it'll have the little loft and a little wardrobe in that. And this right-hand corner here is our ensuite. Now, just going around, but the next panel we've got here is a lime-rendered straw panel wall. And these came through Viva Homes. It's a panel they've been developing. So the 2 panels are brought already completed on site, onto the site, and they're screwed together. They've got a little system they have of doing that, propped up, and it's like a plasterboard finish. They have a V joint, and they can tape that. You can see the tape just here. And that's been rendered over, and that can eventually have an earth render over that wall. We've got some earth renders, and that'll be, because it's an exhibition space, that'll be a projection wall for a little projector, a computer projector. Over here we've got the hempcrete wall. We thought it was important to have a wall with that in it. Hempcrete. It's the hemp hurd. It's not necessarily the fibre. The fibre is better to be used for clothing and whatever. But the hemp hurd, which is a waste product, is a great product for use as a building material. It's got a lot of little air pockets in it, so it insulates well. And that's actually has lime with it, so it's a lower energy material, and that's put in a removable form, but a much lighter form than the rammed earth. And the forms is set to blocks by little batten screws. So when that's rammed up to a certain height, you can take those blocks out. It's quite a clever little system. So you start with your timber frame, you get your roof on first, and then you'll do your hempcrete wall. And then later on, that has to be rendered because it will absorb moisture. But in some cases, if you're inside, you could actually leave that as an exposed finish. Some people really like that finish. On the southern wall, what we did, we thought we'd put a frame wall in with recycled timbers, only because the south wall is an energy loss wall. If you have a masonry wall there, you will get heat going out of that wall because the winter sun isn't hitting that wall. So it's a good wall to insulate. And also we had a shower here and a kitchen with sinks and benches against that wall and a pantry over that corner, which means you're not really going to see a lot of that wall too. So we thought it was a good chance to get insulation in there, cut out a bit of the thickness on the south wall, and at the moment it's got sarking on there just to protect the building. The other thing we could look at this stage is the floor, and we could have done a concrete floor right through on ground. You could even do a timber floor or whatever, but what we've done is a round earth floor. We've done screeded round earth screeded floors before, but we wanted to, Martin Rauch does a lot of round earth floors. There's a little bit of work in it. Now this front part hasn't been sealed yet with our casein sealer, but the back part has, and you can see the difference between the two. Bits are picking up on this front wall, but the back wall is actually quite sound. Now on top of this sealer, we'll put a liquid wax finish and let that soak in a little bit, and then you put a Canauba wax sheen. We'd love to have that here today, but that's part of the process of building our buildings. The other thing with the fit out, what we're looking at doing in the kitchens, there's a lot of waste in the building industry, and a lot of kitchens get pulled out and they're really just taken to the tip. And really, in the past, we could buy a kitchen for $500 or $1,000, these recycled kitchens, but now you can actually get them for free. People are giving out really good stone bench type kitchens. So what we're looking at doing here is refurbishing those kitchens and putting them in with PC items. And I think we're looking at about $3,000 to put a kitchen in with all the sort of elements in it, which is quite a lot less than what they normally are. So with this house, we've got certain allowances for the elements. So in that 50,000, it does include the fit out of a kitchen and your bathroom in with tiles. And again, what's that? Plumbing goes in the walls. That's again a reason for the frame walls. We can put all the pipes in those quite readily. Drainage would need to be put in there, but because it's on an earth floor, it's very easy to take that up. And in this particular building, we won't be putting that plumbing in there, so we didn't put it in, but normally it would just go in before you put your floor down. That's a fairly standard way of doing that. So we're looking at a certain amount of recycling in the kitchen part of it, but a lot of it can be new materials. A lot of the rest of it would be or could be new materials. Once you start using a lot of secondhand materials inside, there is a cost saving in materials themselves, but the labour content for a commercial thing would be more than the saving. So in that case, we wouldn't use that, but certainly for the kitchen, we could. There are economies in using recycled materials. And of course, if owners are doing their own places, there is an economy in them recycling things. With the windows, what we normally do is we'll make that window frame out of in this case, a BAL 29 timber that's made out of blackbutt. And we'll put a louver frame in that and have louver glass. And we like using louvers because they give really good cross ventilation in summer. And so you get that night cool air into your building to cool down that mass, and it works. Then you can close up a bit more on the day if you need to, but often we keep it open. And with this one, we'll have a high louver window, and that means you can get that night, the heat out of the building. So you get an airflow through your building, so bringing the air in when it's cooler, then it go out when it's hotter. With the earth, another advantage, as well as the environmental advantage, is that it's an ideal material for in fire areas. So it's a fire resistant material, of course. We mentioned that with this is BAL 29 timber. If we had to go to higher bushfire attack level timbers, we'd be looking at some sort of screens or stainless steel screens over it. And there are shutters now you can get made with a fire blanket, and those fire blankets just go to the whole window. And that's a way of getting up to your flames categories. In your roof, you'd have to have like a sarking, a fire resistant sarking that has to be strapped down to all your edges. So if the roof sheet's lifted in a very high fire area, you wouldn't get the embers there. And also Balfour here and flames, they would require steel on the outside. We couldn't use the timber. But with BAL 29 timbers outside, we can use up to BAL 29 with this particular building and still have that timber finish. I think it's probably a good time for questions. If I've probably got through most of the areas. If anyone's got any things I want to talk about in detail.
Yep. Okay. There are some good questions that I can see here. This is from Rory, and he asked, when you say 50K budget, is that with or without volunteer building help?
That's without. That's commercially built.
Mm-hmm.
So this one here costs us a lot less, of course. because a lot of volunteer input, and we're just doing as funds become available. But we wanted to get something up to show people what was possible. But yeah, the 50K is our budget. We've done a spreadsheet analysis of things, and we've given a reasonable allowance for each of the elements. And so what we'll see is some different people involved at different stages in doing each of the elements, like a rammed earth team or a mud brick team, or someone who refurbishes kitchens, or indeed the secret garden here. We're looking at putting a kit together with the volunteer people here, so they can actually sell a kit to a builder. So all the elements that have pre-processed, you know, the roofing and gutters, and your kitchen would be already set up, and any PC items could be bought in bulk and they could be distributed that way. So that would be ideal. That wouldn't just be people here. Other groups could do the same thing. It's just a way of connecting everything together. I mean, a builder could do that himself, but if groups were able to do that, they could, say, for instance, sell a kit.
Okay.
I would look at maybe 10,000.
Well, thanks, Ray. So the next one comes from, I think, Latch. I don't know how to quite pronounce that. So in terms of the footings, what is the method of ramming and the pressure for that, to do that? Yeah,
okay, footings. Now, you can just put down a standard concrete slab footing, which would be fine. But what we've found, we can do a footing using some road-based material, crushed sandstone material. That's what we've done here. We've pushed that down, and we've done what's called a plinth beam. You can see it here. It's just it gets up to 150, 200 thick beam, the width of the wall, plus a little bit for termite control inside. But outside, we're looking at a 76 mil, at least, inspectable edge for termite inspection. And that has just two layers of just 8 mil trench mesh going right through, just to tie it together a little bit. So what we want to try and do is minimize the energy that goes into the buildings in the concrete part of it. But concrete is very good for giving you a really good base to a building. Sitting it on the either gravel, you can have a 40 mil gravel, or a road-based footing, which is much cheaper than concrete, of course. So you've got that really stable base. And then we wanted to put an earth floor inside just to reduce that edgy load. So the footings then are, in this case, a plinth beam, and that of course has to be enough to take off any load. But they can, as long as you've got a good gravel road base footing underneath that, or foundation underneath that footing beam, it would be able to take these loads quite significantly. I mean, these walls can take quite a lot of load in themselves. They can take multiple stories. I mean, in terms of compression load, 10 stories would be easy, and actually done in Yemen. They have buildings that tall, and engineers are saying you could even go to 20 stories. Really, in terms of just compression load only, there are lateral forces and torsional loads that you need to take into account with the building. Yeah, but in terms of footings, yeah, very simple footing. We call this our plinth beam footing. And again, we're trying to just cut that energy cost of the concrete going to a building.
Thanks, Ray. So Sue asked a question. I think many of us have asked this before. Why the arched doorway?
Because we can. Well, we had an arch form, you see, and we got some rammed earth equipment from Western Australia. They're really the pioneers in Australia, and really the leading edge people when it comes to formwork. With rammed earth construction, 80% of the work is the formwork. So you've got good quality formwork, you can really do things quite efficiently. Their cost per square metre is half it is over on the eastern states. They've really developed through Steve Dobson and others. Arch form, they'd finished with it, and we had that quite a solid form. It has the chamfer was already built in, so we thought that's a lovely element to put in a building, which is quite would cost quite a lot as a one-off, but because they've already got the form, again, that's just showing how you can have standardized forms for cheaper buildings, but really add something aesthetically to the whole finish. So that's why we had it.
Okay.
Yeah, good question.
Thanks, Ray. This is one from Tone Nat. How does the rammed earth wall cope with absorbing summer heat even without direct sunlight? Direct sun.
Yeah, well, I think the thing with some you're on this building, Again, as the sun gets low, you will still get some heat on, but it won't be enough to really heat up that building too much, those walls too much. So it is important with shade. And again, Eric's here working our permaculture garden, and they'll be putting trees and just shade. And trees are really the best way to shelter from that western sun. The western heat is really the worst heat in that. The northern sun is quite high, and so it really doesn't hit a wall. And sometimes the eastern sun can be an issue, but in this case, we've got more insulating walls to the east. But it's this western rammed earth wall. Yes, it is a thing you need to consider because it can be a heat load. But in this case, because it is so thick, and we're mitigating all the heat gain by shading and by the vegetation, which I think is the best place to start.
Mm-hmm. Thanks, Ray. Talia asks, oh, hang on, we've just jumped somewhere, let me see. The south wall is not using a vapor permeable membrane. Why?
Well, that sarking does have holes in it, so it theoretically is a vapor permeable membrane. I mean, it's not as good as some other things, and yes, we try to keep away from foam boards and things like that, which does stop that vapor permeability, which is an important thing to have in buildings. Once you've got an earth wall, it is vapor permeable, and your hempcrete is, and your straw panels are too. So yeah, that's something you want to try and do. So with that, you make sure it has got the little holes in it, so there is some sort of vapor permeability. It's not as important as it would be in a much colder climate, but yes, you still need to get that vapor permeability with your walls. So yeah, good observation there.
She's looking very carefully. So Martin asks, what direction does the house and land face?
Okay, so the main door is west, and our glazing to the sorry, I've got a phone call there. I'll just the one to the side is to the north. So you can see now that the sun coming in there. It's just afternoon, winter time. That's exactly what happens. That's how the sun comes in. That's what we're looking for. Mm-hmm. So that's the main two elements. There is a little eastern window for the bedroom, and then a high eastern window. Another small northern window for the bedroom, and both those windows can shed light or warmth onto that internal wall. So in the main building, that internal wall will go right to the ceiling. Here it's just made as one open space. So it is fairly close to the coordinates. I think it's not too far out actually. It's a little bit off, but it's pretty close to north-south. The idea is to try and keep your house pretty much to the coordinates and not be more than 10 or 20 degrees off. Otherwise, you start to, the sun angles get too low and it's hard to control them. So our eve on the north there won't get a summer sun in with this building. That's what we're looking for.
Thanks, Ray. Martha asks, I would like to know more about the fire-resistant nature of the house. In the recent Currowan fires down the south coast, any bit of wood caught fire and the house was gone. That's
right. So you really need to, with these sort of houses, what we're looking at is a unique opportunity to do safe refuges for people, because you've got a small space. The earth obviously is going to perform very well. The roofs can very easily with the sarking get up to flame zone, but the outside members, if you're getting it to be flame zone, it has to be all metal, and you can do that. And make everything metal, and they need to be the top sarking needs to be sealed properly against your wall, so that any embers can get underneath your roof. They're not going to affect the building. So that's not too complex. The windows then also need to be those higher levels, and now even Stegbar are doing flame zone resistant windows. So that's all very recent, and even though they're very expensive to start with, now they're actually becoming a lot more affordable. So in areas, again, different areas have different categories, but as a bunker, you really want that flame zone sort of category, and because it's a small building, you can get up to that level. It's not a small space. It's something that could be rented out to someone. It could be used, so it's a useful space. And that's what we're advocating as a great way forward with people on blocks. If they've lost their houses, they get something like this up. It would be a fire bunker. It always would be a fire bunker. They can live in it for a while until they build another house, or stay in it if they want to, because they're quite nice anyway. But they can rent that out as a rentable asset on their place. So And we're just talking with councils now with zoning. Some areas that they're not allowing secondary dwellings because of evacuation issues. And we're saying, well, if you put a fire bunker type building up, it will give residents an opportunity to have more safe refuge on their places. Also for fireys, if they get caught, they've got a safe refuge as well. And also it means you've got more affordable housing, and be a way of putting affordable housing into the mix. At the moment, most of the secondary dwellings wouldn't necessarily be affordable. So there are a few areas where that's been happening that we could probably tick quite a few boxes, and quite a few councils have showing interest in that. So that, I think, yeah, especially in the places where fire affected, where we were at Bowen Mountain, most people felt like they had to leave because the way they described it was they didn't feel like they had something solid they could stay in. And so that's where we want to address that. We've got something that actually gets up to flame zone resistance, and something people could feel, I could dive into there if there's a fire coming through, because if they're on the scene, they can protect their house and whatever. If they're not, they can't. It's simple things like turning on the pump. I mean, typical petrol pumps, you turn them on, they'll last an hour. And it can be well before the fire front comes through. They run out of fuel. They can't be there to put more fuel in or whatever, or supervise what's going on. So having that refuge space is really important, I think, particularly as we saw during the last fires, where there's such a call on the RFS, and they can really only stretch so far. And I think it's when people can feel like they've got a way of defending their space, they're able to do that in a lot more effective way. So, yeah.
So, Ray, just an extension of that, my understanding is that there are no standards or codes for bunkers in Australia. Is that true?
Yeah, I think the problem with the bunkers is because they are small, you do lose oxygen levels fairly quickly out of them. And also, the other thing we're finding with the earth buildings, you've got a lot more mass. With a fire, it's really hot air. And so if you've got mass that's cool, it takes a lot for that hot air to warm up that space quickly, because the turnover period is very quick in a fire. It might be 2 minutes to 10 minutes is your typical fire front coming through. We've heard of longer ones in Victoria through the Black Saturday fires, but even there, some of the earth buildings there survive very well, often protecting 3 or 4 families in valleys where other houses were gone. So having more building stock that's solid for fires is probably what we need to be looking at a lot more. So I think it's actually a lot better way to think of a small dwelling rather than a bunker. That way you've got this ongoing use. It's really not much bigger than you'd build a bunker, but it's actually a lot more functional size. So, and it's, I think it's got a much more broader application. I think in the end probably safer because you've got that more space to it, and you can build it to that higher level. So we're looking at either situation we put an earth roof and this sort of thing on these buildings too, and that would probably get well, certainly a flame zone, but we can do flame zone roofs without that. And I think there's just a cost in that when you've got your PVC liners, and then that can melt. So you're going to have earth on top, and then you're going to maintain plants and that type of thing. I mean, in some situations that could work quite well, but not all situations possibly. So yeah, I think in terms of bunkers, I think that's the problem they're finding with bunkers is just the size. And getting mass properly into a building, and waterproofing if it's an underground sort of thing, and also the other problem is, how do you defend your space when do you go to the bunker, because you want to be around your house and having water access to it, and how do you control your water supply and whatever. So that could be more effectively done from a small building than from a bunker. So there's a lot more than just having a safe space. Yeah.
Mm-hmm. Okay, thanks, Ray. So Rory's question is, what is the star rating of this house?
Star rating, okay, that's an interesting one. Well, we'd be going, I think the latest basics in terms of stars, we go up to 6 stars. But what we're finding with a lot of our earth buildings, people don't use fossil fuel energy to heat cool. Well, by definition, that's 10 stars. So, I mean, really that's the kind of where we're aiming. I mean, people may prefer to put a jumper on or whatever, but we're certainly 6-star house is quite reasonable. And a lot of that is to do with the roof insulation. You make sure that's adequate, and any other insulation that's getting on, which is in New South Wales, we work with a system called Basics. And we don't need to find a star rating. We just have to make sure it's compliant with Basics in each area. And So that's how we work, and we get these through basics quite readily. So star rating can be an interesting one. I mean, we've had tests over in Western Australia done with rammed earth walls and 6-star rated houses, and the 6-star rated houses had to pull out of the testing very early on because the testing was without air conditioning. They couldn't live in their houses where the rammed earth houses were. Went through the testing, and they had insulated, uninsulated rammed earth. And they were designed by top thermal modelers, so they were actually performing well, but they didn't have to have the actual insulation we normally see in houses, and they didn't have to have air conditioning at all in their climate. So, and if you don't have to have any fossil fuel loading, that really needs to be what we need to be looking at. Whether you use slow combustion heaters using a wood source, if you've got a cheap wood source, with our own place, we're trying to. We've often got dead timber we need to be getting rid of, and we don't buy timber in. And those situations, it's to use biofuel is actually a good way to heat and cool. And that's a way we need to look at the rating, that we're not, the star rating is something, obviously, but really how we use our fossil fuels is really what we need to be looking at a lot more. I mean, it is good to look at efficient houses for sure, but there's actually a little bit more to the picture, I think.
Thanks, Ray. Here's another one. This is one from Rowan. How does the building go with complying with NCC requirements and obtaining a certificate of occupancy for a Class 1 dwelling?
Yeah, well, that's a good question. I mean, now with NCC, it's interesting to note that even though the earth building component was pulled out of the original writer of the Building Code of Australia, he had a sympathy towards earth building and put components in there, which unfortunately got drawn out for really no reason, I don't think. But anyway, there still are parts in there with the bushfire. But even brick veneer was only just put in just recently. So for something being in the code or not, it really doesn't matter that much. So everything now has to sort of go through more as an alternative solution. But that's not, I mean, that doesn't mean that need to be that complex. So the Earth Building Association of Australia have a book, Earth Bricks and Rammed Earth in Australia. And we use that little booklet. So we $25 booklet, $20 booklet if you remember, whatever. And that we give that to council, and they can see that there's a way of testing and a way of constructing that is acceptable in Australia. And so you use something like that to start with. Then you get maybe an engineer or an architect to actually reference that book and say that that's a way forward. And look at any existing practitioners in the area that can help you through that whole process. So it is a matter of constructing something together if it hasn't been done in the past, but generally in our area and most areas we work with, we hadn't really seen any issues we're going through. But you do need to talk about the structural integrity and the structural integrity of your material. For instance, you make a brick and you drop it, and the way that breaks, it tells you whether the brick's strong enough or not. And the weatherability, you can, there's a spray test that tells you a weatherability, that you can work with that. And also there's a little wet-dry cycle test which tells you whether you've got too much clay. So there's a few tests, just a suite of 3 or 4 tests that you'll put through, mainly for quality control as you're choosing your building material. And also the drop test we use, we get a sample of soil, right moisture content, has to form a ball in your hand, you drop it from shoulder height, and half that has to break, half that has to stay. And that's an important test for us, the rammed earth, and that quality controls the strength and durability of our rammed earth more than anything else. So there's a few tests like that we spell out, and that's worthwhile doing for the NCC requirements, because you have to show structural integrity and weatherability and durability. So that's what you're looking for the NCC. As long as you put that together, and you need to have that together because everyone needs to know that, yourself as well as certifiers, that's the way forward with it also. But yes, there's no problem with doing earth at all. I mean, there are quite a lot of requirements in the BCR, it's particularly written to allow all these different earth building, or all different building types, really.
Right, thanks, Ray. We've still got quite a few questions to get through here.
Sorry, I'll try to be short of the answers.
LG's asked, can you please explain bathroom drainage detail? Will there be a step up to the bathroom, or did you rough in before the rammed earth floor?
Well, in this particular case, we weren't putting, as I said earlier, we weren't putting the drainage in, but just standard, what you do for any any plumber would go in beforehand. You have to make sure your drainage is in, and you can step that down so that you don't have to step up to something, so wheelchair access and whatever. Yes, it's all fairly standard. And we're finding with the waterproofing now, you can just waterproof over that even, as long as it's waterproof properly. We waterproof timber frames, so that would be okay to actually waterproof that and then tile over it. So that's all okay. But the drainage would need to have gone in beforehand. But because it was earth, we can dig it up quite readily and still put the drainage in. So if we needed to, so that's one of the advantages. You can still do that with that concrete, of course, too. But it is easy to do that beforehand.
Right.
Again, with all these bathrooms, you do have to have the full wet area flashings in place, whichever way you do it. And that's the most important part with waterproofing.
All right. What about that? Someone asked, can you go with single glazing instead of double because the thermal mass internally helps counteract the heat loss and gain from the windows?
Yeah, a little bit. Well, this is all single glazed here. I tend to work with areas, if you've got snow, yeah, double glaze is not a bad idea. If you don't, it's probably a little bit more optional. I mean, south coast of New South Wales, it gets a bit cooler down there. You might want to put some double glazing in. A double glazing is quite affordable now, and you can get different low E sort of finishes on it too, which can make it even perform a little bit better. So budget-wise, it's not such a huge consideration but with louvers, it's very hard to double glaze them. So they're all single glazed anyway. In fact, all the windows here are louvers because we just like to get that extra control. So you've got ventilation in summer to draw in that night cooling air so we can cool down the building. And that helps moderate those day-night temperatures, particularly in areas where you've got a big fluctuation, but your average is fairly close to pretty good temperature. These buildings perform fairly well, and the louvers work really well, and they're all single glaze. So I don't think sometimes put out there, as you say, because you've got that moderation effect from your mass building. If you don't have that, you're really relying on that external envelope to be more of a barrier. And so yes, that's where double glazing would come in a lot more.
Mm-hmm. Kathy asks, are there many companies who can provide the rammed earth expertise?
There's not many, actually. Rammed earth is tricky. We're just putting this up because we can, and there are probably only a handful of rammed earth contractors in New South Wales. So in that case, if you didn't have access to a rammed earth contractor, obviously the mud bricks are actually quite a good way to go. And you can do quite thick mud brick walls. We've just done this here because we could, but generally a little house like this, a 200 thick mud brick wall right round, like you've seen in the corner there, it's just fine. And what we'd normally do is get the floor down, we'd put the roof up next, we'd make our mud bricks on the floor, and then after a week or so when they're dry, just put them on the wall. And that really suits an owner builder or even a practitioner. It can be quite time effective.
Mm-hmm. Okay, thanks, Ray. Can you talk about the fire resistant eaves? It looks like corrugated iron.
Yeah, so at the moment we're up to looking at roughly bale 29. Some of the timbers aren't, they're just recycled timbers, but those front ironbark timbers are bale 29 timbers, and you can use black part and spotted gum as gets you up to bale 29, which is bushfire attack level 29. It's 29 kilowatts a square metre sort of heat load. But to go up to 40 kilowatts a square metre and flame zone, the outside has to be metal steel, and we're using rectangular hollow section. They just paint up a dark color, and it actually looks quite good. Actually, it's quite reasonable, and of course you can span a lot further with metal, so you don't need so many rafters coming out. So we can still do the internal timber structure in the roof, but the outside has to be metal for those higher bushfire attack level categories. So even bale 29 is a fairly high level, and so a lot of bush areas, if there's a little bit of, it's not too steep a ground round and not too many trees, you have a little bit of a bigger asset protection zone, you can keep it to bale 29, so you can use your timbers. We try to get our buildings to bale 29s just so we can use the timbers, but we do use those fire resistant timbers. There's about 7 timbers you can use for that.
Mm-hmm. Thanks, Ray. Is it only compacted road base under the rammed earth floor?
Yeah, well, it's not even road base. We use crushed sandstone. So we've got crushed sandstone within 100 mil of the floor, We've compacted that. We've put a bitumen layer right through, so it seals right up to that plinth beam. And then we put 100 mil of a fairly well formulated sort of rammed earth. It's not just road base; it's a combination of a crushed sandstone and clay, and it has to be. It can't be particles much bigger than about 40, 50 mil, because it's only a 100 mil layer for that floor. And so we've done that, tried to ram that, got the moisture content right, and ran that in one go. But we've had to come through later on and had to finally sieve mix right moisture content just to put into the top. We've got to work that top layer. But there's a fair bit of work with a round earth floor. It's fair bit of labour component to it. If you're doing it yourself, it's cheaper. If you're getting someone else to do it, it's probably dearer than a concrete slab. So, but it's a nice floor, and we wanted to show that you could actually do it.
Mm-hmm. Thanks. Is that low construction cost valid for regional towns or more remote areas too?
I think it would, particularly if there's any owner-builder input. And the mud brick again can be locally sourced, and a lot of the materials can be locally sourced. And it really depends on your construction team. Then, I mean, for us, we need to find local people who are willing to take that on, and that's what we're looking at the moment. It's finding a network of builders in different regional locations that would be willing to take on this sort of building. We've found an interest with quite a few people who actually want to do that. And if people would have to explore that a little bit if it's a lot further away from where we're operating. But we've got people at west of Sydney at the moment, and as a builder from up Coffs Harbour is also quite interested. In the South Coast, there'd be builders we'd know would be quite interested in doing this sort of thing. But in other areas, we might have to establish more contacts with local builders and assist them with some of the just the kit of the home or whatever. They can put that together themselves. And certainly our plans are quite available to people. We don't mind people just grabbing that plan, just using it. It's just something we've spent a bit of time on putting together. For the smaller house, it's fairly intensive design, but as you make it a little bit bigger, it's probably easy to fit in. Under the compliant development in New South Wales, you can go up to 60 square metres. This is a 30 square metre home. So you do have a little more room with compliant development. Compliant development can't be on rural blocks. It can only be residential blocks. So that does restrict. But if you do that on a more rural block, it would need to be attached to an existing dwelling.
So Deb says hempcrete. I did a hempcrete infill wall, left it raw, loved it. Acoustics were fabulous, but it crumbled. Is that wall really reliable to be left raw? I ended up line rending it, changed the acoustics significantly.
Yeah, well, that's right. I think with any lime cement type product, you do need to make sure it's cured properly. It has to be covered. If you don't quite cover it that well to start with, it dries out too quickly. It could be a little bit crumbly. It depends on how much lime you're putting into that mix to start with, and there's a few different variables there in terms of getting that crumbliness. But this wall here is quite sound. I mean, obviously it was done right. It was cured properly, and some of that you wouldn't allow any of the outside to be not rendered, because it will absorb moisture and it'll rot stuff and it'll be unpleasant. Inside, I think if you're outside of a wet area, like in the high part of this bathroom area, we could leave that if you wanted, but you probably want to put some sort of little sealer or binder on the outside of it, because it's a little bit crumbly on the very surface, but a very pretty wall. And it would be very good with acoustics, because those little spaces would absorb sound really well, actually. But again, if you're in an area with a shower or a bathroom, behind a toilet, but certainly not in a shower, you'd have to really make sure it's rendered and sealed up pretty well. So you just got to really look at that situation with your hempcrete. And also at the moment, a lot of these products are imported, which is a little bit of an issue because the quality of the herd in Australia is not that good. Because we're not using the fibre over here, the fibre is often integrated with it, and that can tend to clog up mixers and things like that. The lime they're using is a pozzolan lime they're trying to use, but really we could do that here with a bit of a clay addition. But at the moment, that's not really available in a commercial form, and so a lot of it's being imported. And again, they can import things at a reasonable cost. There is a little bit of a cost in the hempcrete just with those raw materials, but certainly it's a very low cost if you look at the whole wall element. So it still becomes quite an alternative way we can look at doing walls. And I think the system with the formwork, the light formwork, is actually quite a good system. It's just a nice way of doing that. We have workshops here at different times. We had a workshop here to build this house, a lovely workshop there with different teams of people, and had a great hempcrete team here. And they were showing how that was all put together, and that the same principles can be used for light earth, the same formwork, and also the straw panels. So there's ways we can do that. But a lot of that detailing, yeah, it's worthwhile getting up to speed with.
Mm-hmm. Ray, how does the rammed earth go with white ants, the rammed earth floor?
Well, this is why we have an inspectable edge of that plinth beam. We just extend it out from the wall a little bit. So if termites are going to get into the wall elements or into the roof elements, they've got to go around that little inspectable edge. Now, if you've got wooden furniture on that earth floor, you've got a problem. So here we don't seem to have many white ants, which is really weird. I don't know why. It's just a sandy site. We just really haven't seen it here. That's a bit unusual. Most places in Australia do have termites. So that is a real issue with floors. So that's all we can suggest at the moment, is you extend that plinth beam a little bit wider, so you've got that inspectable edge inside, and of course we've got the inspectable edge outside, and so you've got a visual inspection of termites getting into your building. But you might want to put metal pieces on the bottom of your chair legs or something, or tables, because that is an issue. If any joinery that goes in, the kitchen that goes in, that would be an issue. So you might have to put some sort of a termi-mesh base underneath the kitchen, just so that, and tie that to the plinth beam, so that's, you've always got that inspectable edge. So it is an issue, and it would need to be thought through with the earth floors. It's one of the problems with an earth floor. So you've just got to work through that. If you've got a termite issue, you may be better, well, put a concrete slab, then an earth floor, if you really like an earth floor. But the concrete, we just find, is one of the most affordable termite sort of barriers. So if you can think about how you can use that, and that's probably the way to work through that one. You know, we try to not use chemicals. Obviously, use chemical barriers. Some are getting a little bit better, but and there may be barriers that you can use. Some people have used lime underneath. The granite guard doesn't quite work in that situation. It's more in a situation that can collapse on itself and stops the termites building tunnels. But in a solid situation, it doesn't quite work as well. Yes, I know you can put termi-mesh right through, but that's a pretty high-tech sort of solution. So it is a tricky one to work through. We haven't come up with anything more than that little inspectable edge is fine. That's the probably the easiest way to work through that. And I think it's pretty reasonable. You just have to keep expecting your furniture, that's all. And it can be an issue.
Mm-hmm. Ray, what are the internal dimensions of the interior spaces?
Okay, so yeah, well, on that plan, I do have the dimensions there. I don't know if you want to put that up again, Doug, but what we tried to do is with the outside perimeter, make it 30 square meters. So it's 5 meters by 6 meters, 5 meters across that gable and 6 meters deep. Mainly because with 6 meters, we can get that 2 rooms. Otherwise, very difficult to get 2 rooms in 5 meters. And we really wanted to keep that 30 square meter footprint. So it means with the 300 rammed earth wall at the front, that's coming off the length, and you've got a 200 wall in the middle and a 200 wall at the back. So 700 off your 6 meters is 5.3. We divide up, and the I think the back room was, I'm not sure, I can't see it, but 2.6 I think, and then a little bit bigger on the front room. I think it's close to 3 meters, probably a little bit under 3 meters. So it's enough to get I don't have the furniture drawn in that layout, but we have done furniture layouts. So you get a dining table in the middle, and against the internal wall, you could have a lounge chair, and you can do a piano on the other wall if you want, or another lounge chair and a table. So it's just enough for 1 or 2 people in a small house. If you had a small child, you'd have to work your way around it, but you could probably even do that too.
Mm-hmm. So Ray, you spoke about articulating the clay when making the rammed earth wall mix. What does articulating mean?
Articulating, did I mention that? But articulation means you break up each of the elements into a panel, so that if there's any movement, any cracking will go along that articulation joint. With a small building like this, and if you don't put cement in your rammed earth, like we're not doing, the wall's a lot more flexible, and so you actually don't need to put articulation joints in our walls. We've got 30-meter long walls, but normally with the cement, I think they're down about 3.5 meters now, 3.6. It's as long as you can go with the rammed earth wall before you've got to put an articulation joint in. So most of the rammers now, they have a system of ramming their walls vertically and a system working around the windows, so they have these articulation joints. That's fairly common in modern day rammed earth with cement, but with these, because you've got a little bit of micro cracking right through the whole structure, with a little bit of shrinkage, we tend to find there's a lot less cracking. You can get cracking sometimes if you've got a thinner piece underneath the window, and sometimes they put a little bit of reinforcing that, some sort of mesh or whatever, just to stop any cracking there. So you can get cracking. Here we've got a little bit of cracking over the arch at the moment, and that was just a settlement crack. And again, with this rammed earth, because you haven't got cement in it, we find it's very easy to repair. You have to wet your wall down, just spray it just gently, let that moisture soak in, get your moist mix, and you can actually ram those pieces back in again, like weld them in, which is very hard to do with a cement stabilized wall. So even if you do get some sort of articulation and cracking, we can mend them pretty quickly. So it's just part of working with your structure. So it's not such a big deal.
Mm-hmm. Thanks, Ray. Look, we have come to our hour is up. As I said, we are going to continue, but for those people who are leaving now, I'd just like to thank Ray for his tour, which I think has given you a whole lot of information. Andrew Lee, of course, who is one of our members of the Sydney West Renew branch, and of course Doug Rolk, who is the branch coordinator from Melbourne for all the branches in Australia, and he has done a fantastic job getting this done for us today. So for people can continue on, but for those people who are going to leave, thank you very much for attending. All right, next question. In explaining, in explaining the roof ceiling construction, Ray mentioned reuse office panels. What are these?
Yeah, okay. Well, Deborah here, who heads up the Secret Garden, she had these sitting in. They came out of, with offices, they have this thing called churn, where every 5 or 6 years, they just pull out everything and re-go again. It's incredible wastage in the building system. So you got these really quite refined looking panels. They're not real timber, they're just a plastic liner. I'm not so keen on using it, but because they were recycled, I thought it'd be a great opportunity just to show how you can recycle something that makes it look quite reasonable. So again, it's just accessing these materials that are in our system, that are really getting thrown out and adding to the waste pile significantly. And if we can intercept some of these things and show how they can be used well in a building, I think it's a much better reuse and much better use of our resources. So that's what that is. So it just comes out of old offices, and really they're quite common to find. And they're actually probably a little bit more work than putting the panel in right through in some ways, because you got to fit in with sizes and whatever. But yeah, we still want to be able to use them. Just show you how you can use recycled materials like that. And I think that's the idea with these places, is just being creative with what is actually available. And there's a lot of, as I said earlier, the kitchens particularly. And you know, there's a lot of cheaper PC items now you can get in bulk, and we're hoping to sort of capitalise on that a little bit too. But and the recycled crushed sandstone, which formed the whole base of the whole building, was delivered very, very cheaply. So we can actually build quite cheaply. I mean, so far this hasn't cost us that much at all, this building. And if people want to do, as owner builders, dive into that, they'll find they can actually build. If you're building a lot less, and with this sort of materials, you can really cut the cost of building and make building a lot more available to people, as long as that land is available through, be able to do that secondary dwelling on existing building sites.
Ray, are there any similar projects closer to the inner west?
Inner west? Well, we're not too far away. We're just the outer west. Get on the train and head out to Richmond. Not really. It's a bit tricky, isn't it? We're hoping to do a lot more in the inner west. Actually, we've got a few contacts there where we want to start. I mean, the blocks are pretty small, but funnily enough, the material, the crushed sandstone, came from in town. It was a big hole being dug at North Sydney, actually, and so we're getting material from there. So the material is available in town, and really that was the bulk of the mass of the building material we're using. So we just had a little bit of clay, which you could also get from in a city, and we've done a number of projects where we can work on smaller spaces and just see how you even make mud bricks in town, particularly if you get a roof up and make it under your building. So it can be done, but there's very few examples. There are a couple I've heard of people over the years, but I've sort of lost contact with what they've been doing. But we hope to do a little bit more in the inner west. I think it's a great area to start, actually, because there's a real need for extra accommodation there, particularly for young families and maybe living with their parents that just need that extra bit of space for their parents or for them, and that's quite possible. I think from about Greenacre out, the blocks are getting big enough so you could actually do this quite readily. Further in, it would be more of a challenge. You'd have to work with the existing building stock, I think.
I think that's a good idea. All those children that are returning home to their parents, I think that's a wonderful idea.
Yeah, exactly.
So this question is, could you give more detailed explanation of how to construct the Trom wall? Okay,
Trom wall. What we're finding, roughly that 200mm thickness wall, mason walls are a place to start, which we've got here. And what it's an idea of Ian Circum. He's a ATA Renew member too, and has had articles in some of the Sanctuary magazines. And talking with Ian, he did a little glass wall. It's basically a little glass wall that sits outside, or the actual wall itself. Now that could just be old doors, for instance. It doesn't need to be anything too fancy. And we're finding if you have a window, it's nice. You're not normally a Trom wall would take up the whole wall, and we've done those. But under the window is quite nice because with the glass in front of the wall, there's normally double glazing works better because you don't get the heat loss, but it doesn't have to be. And about an 80mm cavity between. And if you get the masonry a little bit darker, it works better. And then the glass heat winter sun, which is lower, comes through the glass, and with the glass house effect.
Just while they're fixing that, can I just mention something with the next one, which is how many is he building? Ray has also constructed on the site a children's play area, all out of earth building, a wonderful eating cafe area, and a wonderful retail area. And so hopefully with Sustainable House Day this year, there may be a tour of all those other buildings that Ray has constructed. He's an excellent designer, very attractive buildings, and I think people would, they're very creative. He's incorporated coloured glasses and bottles and whatever, and so hopefully you might see that for Sustainable House Day.
Lost a bit of battery or something with the little one, so I don't know if you want to keep going with any more questions or wind it up. I mean,
well, we do have another question. How many are you building? And Ray, just while you had that quick break, I did mention to people some of the other buildings that you have designed and constructed at the Sixth Garden, so you don't need to go into those again. So
yep, I think I provided a couple of pictures of like full scale houses we built at the moment. One of the guys working with, he's doing a 60 square metre compliant development at Blaxland, and we're just starting design on a 30 square metre one at North Richmond. So really, it's not our major work, but it's just we're putting it out there as a way forward for this building here is a 5-bedroom, 3-bathroom house, and this one's a round earth house. So it's two I just put up there, just recent work we've done. So you see earth building done in a modern context and in the larger housing. So it's not just a one-off for small houses. It can be done with any house, but I thought, why not start to look at it in the tiny earth context? So we're really only just starting off the thinking. We're talking with councils about local things, and we're talking to different contractors. We've had some builders who are project managers who'd love to take this on. Ideally, if we can get 3 or 4 in particular areas, that makes it more affordable and doable for builders. And we're getting networks of designers and things who are also interested in being involved in the whole process, and also other suppliers. The rammed earth's a little bit harder to have teams doing that, but again, you really are looking at a couple of days on site for a rammed earth team. So even if there were quite a few, you could program them in and still do them. And there are rammers who are doing that, could do that sort of work. But the mud brick again is more accessible to owner builders and could be probably done by local teams a lot more readily. And also the other, whether it be hempcrete or the straw panels, there's different ways that these things could be done. It's just that concept of what you could put out there. So it's not really up to us. It's just what we're putting out there, and
and this a spreadsheet would be available to any builder, like a little project home, and a lot of builders are seeing that they could all stack together. There's a reasonable margin there for builders in the whole equation too. So if they took it on and had a few, it'd be quite a reasonable income for them. So it's not just based on what we're doing, but obviously we're able to do this thing, but other builders could probably jump into the whole thing too, and are quite interested in doing more renewable housing. That's and some of the architects we've talked with are saying that they're sick of doing lots of concrete and steel. They want to do something that's a little bit more sustainable, and so hopefully this could be something they could jump into too.
Okay, Ray, can any of the heavier wall materials used be manufactured as panels in a controlled factory environment and delivered to site?
Yes.
Okay.
Yeah, we're looking at that. Even the rammed earth panels we're looking at doing, depends on what resources you have on site, but certainly a two-ton panel's not that hard to lift. A bobcat or a fork can lift those and put those into place. Yeah, so that can be done. We've been looking at that. The straw panel that was shown, that's a 1200 by 2400 high panel that could be pre-manufactured, just brought into site. That went together quite quickly on the day. That was just lifted by a bobcat on site and installed. So yeah, I think a little bit of prefab is probably good too. But we're looking at about a 2-week build, maybe 3-week build for these things anyway. So, and that's with constructing things on site. As long as the bricks are made, obviously it's a bit hard to get the drying time in that equation. But yeah, if the bricks are made, we've done buildings twice the size of this in 2 weeks. So with bricks made, so that's quite doable.
All right, Ray, here's an insulation question. What insulation has been used in the ceiling, and what was the cavity size and R rating achieved?
Okay, it was, I think we got a 3.5 R value in this one. I think that's or maybe 4. We put some sarking on the top to give a little bit, just tweak it up a little bit, and I think it was 3.5 with sarking. So I think we're trying to get 4 we're sort of looking for. So nothing huge, but that's I think what the basics requirement was, and that's what we went for.
All right, someone's asked, say we purchase land, what would the approximate total cost be to build to lockable stage, including planning permits?
We'll see. Yeah, well, including planning permits. You've got there's a few thousand involved in the planning permits. What we're finding, these can only be compliant development if you have an existing house on the block. So if you don't have an existing house and you want to build one of these, it would just be a standard DA that going through council. And normally, a place like this, you pay about 2,500 to 3,000 for your council fees, and that would be on top of you know, the cost of building the building. Now, to lock up, of course, this building is almost a lock up, so it gives you a bit of an idea. And there's a little bit in the fit out. You're probably looking at about $15,000 to $16,000 of cost of fit out, which is your kitchen and bathrooms and things like that. So you 50,000, you take that off, maybe 35, I suppose, to lock up, plus your council fees. I mean, 40 would probably get you by and engineers' fees or a few other fees like that. So that's to lock up, and you're probably looking at 50 to. And there's also on-site costs. You've still got your wastewater management to be considered. That's outside the cost of the building. So whether you need a septic system or an aerated system, and you may need reports for that. And there's all sorts of flora and fauna reports sometimes you need, and what's the other one? Bushfire reports. So some of those reports can add to the cost of the applications. So that would need to be taken into account too.
So, Ray, were the walls hand or machine tamped?
We could hand ram them. It's a fair bit of work hand ramming. We had a fairly large compressor and the pneumatic rammers. That's the way we did. The ramming part of it was actually not that much. The biggest job, as I said earlier, was 80% of your work is the formwork. And we've got some fairly good modular formwork that locks together well. And I think with a little house like this, you'd have dedicated formwork that you could put together really quickly, and that would cut your construction time quite a bit. The ramming is not that difficult when you've got the pneumatic rammers. Hand ramming is a fair process, but if you've got a few people working with you, you can have quite a few rammers. It's actually quite time effective too, actually. That's not that unrealistic to do the hand ramming. The main thing is that moisture content of your original materials, as I said, with that drop test, is monitoring it all the way. and make sure, and the mixing of that too, we do that with a bobcat. If you had to do that by hand, it would be a lot more physical work. So if you have some equipment, it doesn't need to be all sophisticated equipment. It is actually a little bit more time effective.
Okay, Ray. Gosh, you're going well. You've answered 43 questions.
Well, there you go.
But there's still a few more to go.
Yeah, why not?
Is there a timber top plate or concrete bond beam at the top of the rammed earth wall?
We don't have one, and you can do them, but this building probably wouldn't really need one. We've just got a timber plate. We've got an interesting system here where we use a beam on edge as the plate, and we bring the rafters into the side. And with that detail, we can use green timber in the roof. And often we do that from local mills. We just dress the timber up, put a oil over it so it doesn't crack too much. And with this detail, we bat and screw them together, and the whole roof layer there can move down and shrink over time. And in a couple of years, you've got seasoned timber anyway. So that's what we normally do with our buildings. Everything has to be tied together and tied down. And depending on the actual design, of course, a concrete bond beam you could put in, but you don't necessarily have to do that.
What's the maximum internal height
of this building?
Yeah.
I don't know what, I can't remember now. About 3 meters, I think it was. I have to try and, was it 2, 1, 3, 6? 2, yeah, maybe 4 meters, yeah. Yeah, pretty close to, just a bit under 4, I think, maybe 3.8, yep. But it gives you a little bit of loft space with a 2.1 ceiling, which would be lower than that window. You can still get a bit of headroom in that loft.
Ray, can you explain the roof construction? Somebody mentions we have only heard about some components.
The what construction, sorry?
Roof construction.
Oh, roof construction, okay. So I sort of talked a little bit about the rafters. They come into that side beam. That's screwed in with batten screws, 100mm batten screws, and then we actually strap on the outside outrigger here at a higher level. It actually comes right up underneath the roof. It's an unusual detail, but it's one we've done for quite a few years, and that gives you roof space then for insulation. On top of those rafters, we put a timber paneling or that recycled paneling, and here we've got a little load-bearing ridge that goes through to a little truss we've made with a collar tie, because our timber wasn't long enough and it wouldn't span 6 meters. You need a much bigger piece of timber, so it keeps your timber sizes down. So that's how we work that. On top of that, we have on top of the ceiling, we have what we call we put a little batten ripping, which means when the vapor barrier goes on top, it's a little bit higher. So then on top of that, we fix a counter batten, which gives a ceiling space, and on top of that, we put a little 50 by 50 batten, hardwood batten we fix the roof to. So it's a standard detail we've got, and that gives you that ceiling space. It probably is a bit complicated going through all that quickly, but that's roughly what happens in the ceiling. And normally what we do with the earth buildings, with a round earth building, we need to get the walls up first, but with a mud brick building, we tend to put the roof up first. And we make sure there's tie downs right to the plinth beam with threaded rod, so that it won't blow away, and then we brace the roof to temporary supports we call TOMS, T-O-M-S. So we brace prop everything up away from the wall so we can build the wall in, and then we hang the actual window off the wall roof, and then we can build our mud bricks in. We tie everything in. So that's kind of the way we sort of work it. And that way it gives you a roof out of the rain and out of the sun. It just makes a much better working space. And it's not that, and also when you put your roof up, you don't have walls to have to work around. You can actually brace, you put your toms in, brace them, and then everything just goes off that. It's an unusual construction, but it's actually quite a cost-effective and time-effective way to work with. So that, what else can we talk about? I see you've got your plinth beam at the bottom. So you've got your skirt. We haven't put one on the mud brick walls. We often do that too. You can put a lime layer or a brick layer there. You have to have damp course, of course, so you don't have the moisture coming out from any. Well, generally the concrete is a bit of a damp course, but it's good to have a bit more damp course, particularly under timber walls. You get a bit of moisture still coming up through your slabs. The window frames themselves, We put a little blinding strip up the edge so you can't see air through, light through, and that's tied in with a frame tie into the actual mud brick, and that sort of locks that in. The sill comes a little bit wider because it's got to cover the mud brick, so you protect that edge of the mud brick. And again, outside we'll put a little a burnt brick sill, just so the water that runs off the window can shed from the wall. So it does. One of the main areas of earth where they're quite vulnerable is with running water anywhere. So running off a sill, make sure your downpipe's a little bit away from a wall. But generally, just rain hitting a wall doesn't really affect them that much, but running water can be quite an issue, and particularly if it's a volume of running water. So that's where we find they're most vulnerable. So it's just protecting those vulnerable areas is pretty important.
Okay, Ray, these are two questions. I'm just going to quickly combine it into one. What are the chances of laundry facilities in the building, and also what will the final render be on the building?
Okay, so laundry, in this particular small building, we'll just have a washing machine in the kitchen. With the next size up, you can have a separate laundry because you've got the space for it. With rendering, what we do with the walls, that's a good question actually, I haven't quite covered that one, but with this mud brick, we've come up with this way of finishing a wall where we actually take material off. We soften the clay and use the clay as a paint in its own right. So the actual finish is actually inherent in the material. And then we can take off more material, expose here, you can see the straw, sometimes more aggregate, or we can have a skim of the clay over the lot to soften the whole feel of it. But the trick is we don't put a slurry on it, we actually take material off. We use a soft broom and we keep on washing it out in water, and like you're grouting a tile, you're taking the grout off, you're leaving the grout in the actual little cracks and joints and whatever, and you take that material off. And you can actually, after a while, as the wall dries a little bit, just with a dryer broom, work over the surface, almost you can get a polished finish on it if you want to. So that's our finish internally and externally. We just find it's quite a breathable finish. With the rammed earth, what we're doing though, we like the off-form finish. We could do the same thing with that too, but we find with the rammed earth, what we like to do is put a sealer on that. We make up with a skim. This is inside. Outside we don't put anything on, but inside we make up a mix with casein, which we mix. We get from a skim milk mix. We curdle the skim milk, and with the curd part of it, we dilute that down and we make that into a casein, which we spray on. And that's the seal we'll put on that. That just gives a more dust-free finish. There are other proprietary plasticky things, but we love the more natural, breathable finishes. So yes, we don't need to put any other lime renders or cement renders on any of the walls. The actual wall material can have that anyway. With the straw bale wall, that's got a lime finish on at the moment, so it's durable during construction. But internally, what we'll do on that, we're going to put a fairly light-coloured clay render. So it'll be a proprietary product where you can make it yourself, where you have the right proportions of clay with aggregate, and that's pretty important with renders to get that proportion fairly accurate, because you'll get cracking if the proportions aren't right. With the hempcrete, that'll be lime rendered, that wall inside and out. You may put some clay render up high, and it may even leave a part of that exposed, but that would be actually lime rendered. And on the outside of the straw wall, they'll actually be lime rendered too, because you don't want moisture coming into the straw. So yeah, but the clay itself, the earth walls, we don't need to use those special renders. You can. There's different ways you can do that, and people do that, but you don't have to.
So Ray, how would the building stand up in an earthquake area?
Okay, earthquake's an interesting one. I think one of the reasons for developing this thinner brick that we've got here was to make a wall type that could be more suitable for earthquake situations. So you've got a thicker mortar joint, which means you can put bamboo reinforcing in a lot more readily in the horizontal joint, and the thinner brick is quite easy to drill through every second brick and put the bamboo. So you've got a whole bamboo lattice within your wall, and you can tie those on the corners. We've done earthquake testing on those walls with that sort of construction. We've got well over Richter scale 8 in performance with those walls, just by having that bamboo reinforcing incorporated into a cob-like wall. With the mud brick itself, without any other reinforcing, they're not so good in earthquake areas. without any reinforcing. So you do need that reinforcing for earthquake areas. The rammed earth, it can take reinforcing quite readily too, with horizontal and vertical reinforcing. Vertical is okay with bamboo, but horizontal tends to be squashed, so you might have to have metal horizontal reinforcing for the rammed earth walls. But rammed earth walls have been done in high cyclonic areas in Australia, and they've had rammed earth houses stand up, whereas old houses that have been there for hundreds of years have blown over. So really, you can design them quite well, but it does. It's worthwhile having engineers just looking at it, making sure you got your tie downs of your roofs properly done. So your thread rod's going to go right through to the top roof, and all your fixings have to be up to cyclone specs in your roof. And it's just and it's really whatever cyclone area you've got or earthquake area you've got. We don't have high earthquake areas in Australia. The highest is in Western Australia. Meckering is our highest recorded earthquake. Up to scale 7, there were a couple there, but there's not that many. And really, even the Newcastle quake's quite low, really. So compared to earthquakes, say in New Zealand. But yeah, they can be done quite readily. But we're finding this bamboo reinforcing, and also the cob, where cob has this, which is the mortar with a lot of straw in it. That's important to make things more earthquake resistant. It gives sort of mini reinforcing to the whole lot. We've got very good results with earthquake testing.
Mm-hmm. Great. 2 more to go. So, with regard to the rammed earth floor, was there a moisture barrier under the whole floor? And what was the method of ramming the material? I'm aware of the very old method of bringing a mob of sheep into the space to compact and add moisture to the material.
Oh, yeah.
Okay.
Well, here we could have put just a polythene membrane through, but I was a bit concerned that it would still be a capillary issue right against the edge plinth beam. So what we did, we had a bitumen emulsion that we actually sometimes stabilise the mud brick with if they're going to be a lot more exposed. In another exposed situation with mud brick, we put linseed oil and whatever. But so here we put a black tar basically. We just tipped it on. I just had an old broom. We just broomed it out and make sure you can even see bits of it over here actually where it's come through here. I don't know if you can see that. So we put that on to waterproof. And that's very important. We didn't do it with a cafe floor over here. We found it was okay for a little while, but as soon as we broke through the linseed oil layer, because it was a garden, the moisture around with the capillary action just came up through it. So capillary action is so strong. I mean, it goes up through trees, you know. So we thought it's very important to make sure this was waterproof. So we did that first, 100 mil down from the top of our plinth layer, and then we got the material, the right moisture content, sieved it right, got the right sort of spread of particle sizes right through, make sure there's lots of aggregate in the mix, and then we used a compacting plate and went over it and compacted it with that. And but then we found we weren't quite able to always get the surface right. And we went through and did a lot of hand ramming of all the edges. We found the hand ramming was quite hard. So we've actually had to hand ram this quite a bit, just particularly all the edges. The plate couldn't get right into the corner. There are more specialized ramming machines that could do all this, but we didn't have access to it with this job. But you see, but with the right moisture content, it's amazing what you can do with just hand rammers. So there's actually quite a lot of hand work over probably 2 or 3 days. And then we had some even steel trowels we were pressing in with that, and that was working quite well. So yeah, quite a lot of work with the rammed earth floor. It's not an easy thing to do. I mean, the trowel floors are easier, but they're not nearly as hard in the final finish. So we want something quite hard with the ramming. Just it really is a little bit experimental. But I think you'll see here. I don't know if you can see. You probably can't see with the detail, but the floor in the back section of this room has already had the casein sealer on. And this here hasn't, so there's still a little bit of loose material around that we need to seal. And then eventually we'll have, as I said earlier, we'll have the wax finishes on it. Mm-hmm. And then you finish off with the melted Carnauba wax, and that gives us sheen level. It's quite I've seen pictures of it, looks fantastic, but we haven't seen ourselves yet here. So. Okay,
Ray, is it possible to see the house in Blaxland?
Blaxland, okay. Blaxland is only just starting. It was only a slab at this stage. So yeah, it'll be a little while before that one gets built. It's got a couple of rammed earth walls at the front and internally, and the rest that's a frame building. So, and it's got a slab, a concrete slab right through. That's just, again, it's what owners were wanting. It's not necessarily affordable house. I get something like $300 a week rent for that house. So that's another sort of category. But it's a tiny house. It was done with complying development through state legislation. Didn't have to go through the local council. So that was an interesting exercise in its own right, and going through a certifier. So that's quite a reasonable process. It's all in train, and once you get through the initial sort of hurdles, it's actually quite a reasonable way to do things. And the actual time for approval is way shorter than councils. I mean, we're finding councils now are getting 6 months to a year to get a building approval through, whereas that went through, I think it was about 6 weeks. And really, if everything's smooth, it can go through in 3 weeks. So quite a more streamlined process for people to get, affordable dwellings.
Some of those, Ray, that you showed us photos just a little while ago about some of the buildings that you've been working on, right? Rammed earth houses. I mean, some of those may be open for Sustainable House Day. Is that possible? Have you opened them before? The Sustainable House Day?
I think people would love to have them open. Yeah, for sure. That one at Cranebrook was done with cement-free rammed earth, and we've just completed the walls, just completing the last parts of walls for a house at Hartley with cement-free rammed earth. So it's the first 2 or 3 after this one for probably, as I said, 40 years, or was it 30? 40 years at least.
So my understanding.
Yeah, so it's just the way we can do it. Yep, that would be available probably.
So Ray, that's our final question. So once again, I don't know how many people have stayed on for all those questions, but Ray, that's a marathon. I think there were 52 questions or something, and you've answered them all. So well done. Thank you for everybody that helped. So thank you everybody. Thank you, Doug, and hope to see you again at another webinar, or maybe face to face sometime.